Finds success of Siemens Aprisa praised and loved. Hmm. ARM is market leader. The ARM is a market leader in semiconductor IP, including interconnect technology that serves as the backbone of many system-on-chips SoCs. Part of the success of their processing chips lies in achieving technology entitlement. At the last user-to-user conference, ARM principal engineer John Mitchell described technology entitlement as more than just chip performance. It's since getting the most of the given design technology. In addition to the key metric in the IC place and routing performance power area PPA technology entitlement at the ARM includes being able to get the most optimal performance power in the area until the micron per, per power area per unit micron during design implementation. Watch the presentation from ARM, achieving highest technology performance on a high-tech interconnected designs with Aprisa. The topic of technology entitlement in mutual presentation led to a discussion around the challenges of their interconnected signals. They found that interconnected performance has a significant impact on the system in which it operates. For various workloads, every 5 nanometer of latency we can reduce in the interconnect, we get a 1% performance increase in our CPU core. Mitchell said, this illustrated in Figure 3. Figure 1. Performance measures the spec 2K6 big core with 1 MB and 4 MB L3. ARM offers solutions for optimizing interconnection designs, and they have been a handcrafted method to achieve technology entitlement. However, to realize the hopes for improved time to market, they need a fully automated place and route solution that understands interconnected designs. This is where Aprisa enters the story. ARM began the trial of Aprisa IC place and route tools from Siemens and looked at how Aprisa resolved a few key implementation challenges, including the global register placement and global routing and track assignment to reduce SI, co-optimizing buffers and layer NVR. Michel said they have just taped out a test chip for a Borrello program to demonstrate, which aims to develop a more secure hardware architecture to processors. And SoC, and however, was in a different technology with different options and interconnect and was optimized differently. Therefore, all of technology investigation, the design investigation and the setup has to be done to build the system, which proved to be perfect case to see how long it would take to do in their current methodology versus with the Aprisa, and find out if Siemens solution could match their result. Aprisa was used on the top level interconnect over the 1.5 billion replaceable instances. We didn't want to just look at the high level and say, yes, it was able to close the timing. We wanted to see if it had a proper understanding the technology and was able to capitalize on it and the way we can with a handcrafted method ambitious. So figure 2 shows the SoC. Results were better than expected. The global placement was similar to ARM's traditional result, and Aprisa made better use of the available space given the modules were not constrained to specific boundary boxes, and it could spread some key logic producing somewhat more than refined result. And Aprisa global routing and stack assignment results in a lower net capacitance and significantly less signal integrity issues. Overall, the Aprisa achieved 90% of the technology entitlement at the push of a button, said Michel. The Aprisa team takes pride in out-of-box experience, and the software comes with a reference flow is to use and easy to customize, and built-in design widget helps with the initial design setup and scripting customization. A process solidified for advanced process nodes from the major foundries, including the TSMC M5 and M4 processes. The AIM plans future trials with Aprisa to match what they get from their handcrafted flow at the most advanced nodes and to explore routing for power reduction. Thank you.